This video is on empirical formulas, what they are, and how to calculate them from some given information. You're going to need to make sure you review or you remember how to convert grams to moles. That was back in chapter 3. So I would take a look back at your notes, see if you remember that. If you don't, I would rewatch that video in chapter 3. So an empirical formula is the simplest ratio of elements in a compound. So, for example, if we had something like a sugar like C6H12O6, looking at that, you should hopefully be able to see that the 6, the 12, and the 6 could all be reduced. This is what we call a molecular formula. Come on, pen, you can do this. And we'll talk about molecular formulas in our next video. But when it's reduced, like it could be in this case, would be CH2O, that's the empirical formula. So we are just trying to figure out how can we figure out or determine or calculate that empirical formula, that simplest ratio. So the key is that this is a ratio. So I've got some steps here to help you out. All right, so first thing we have to do is we have to change our given to moles, and your given is typically going to be in grams or a percent. And we're converting those to moles. And I'll show you what I mean by a percent and what we would do with that. But the grams to moles piece should be review. All right, then you're going to compare your moles that you've calculated. Hold on. And you're going to take each one and you're going to divide by the smallest number of moles. What that's going to do is it's going to give you a ratio to 1. Whatever your smallest amount will be 1, something else might be 2 or 3 times as big. Those ratios then, that 1, that 2, that 3, those are going to be your subscripts in your formula. So these ratios need to be whole number ratios because we can't have 1.5 hydrogens or something like that. And you may get into a situation where when you divide, after you do step 2, that you find that you do have like 1.5 to 2, which will not work. So if that's the case, so whole number ratios, come on. So if they're not whole numbers, all right, let's try this again. So if not, you'll need to multiply to get whole numbers. So I can show you what I mean by that with an example in class. All right, let's just do 2 more, a little bit more basic examples first. So we're going to first look at number 1. It says determine the empirical formula for a compound containing 2.128 grams of chlorine and 1.203 grams of calcium. So we've got chlorine, we've got calcium, and we have an amount for each. So our step number 1 is to change grams to moles. So here's where I need my periodic table. So if I have 2.128 grams of chlorine, my conversion is I need grams to cancel. Remember, this given is over 1. So grams of chlorine would be in my denominator. Moles of chlorine is what I'm converting to. That's in the numerator. 1 mole of chlorine, the gram number is 35. 35.45. So I get that from the atomic mass on the periodic table. So if I do this math, the grams of chlorine divide out, and I will get 0.06003 moles of chlorine. All right, now I have to do the same for the calcium. So 1.203 grams of calcium. So I want grams of calcium to divide out, and I'm going to convert to moles. It's 1 mole on the periodic table. Calcium's atomic mass is 40.08. So my grams of calcium divide out, and when I do the math in my calculator, I get 0.03001 moles of calcium. Make sure you can type this in and you get this answer. You should be dividing here. So now I'm ready for step 2, which was to compare the moles by dividing each by the smallest number. So I look at these two values. Okay, I've got this one 0.06003, and then this one 0.03001. So the smaller is 0.03. So I'm going to take both of these and divide by 0.03001. So when you have something divided by itself, you get 1. So that means I have 1 calcium. And this one you can probably see without even typing in your calculator. It's not going to be perfect. It's not going to be exactly a whole number, but it's going to be very, very, very close. Like 2.0 something. So this means I have 2 chlorines. And the reason it's going to be very, very, very close and not exact every time is just rounding. So this means I have 2 chlorines for every 1 calcium, so Cl2Ca. Now, this is not quite right. We are not quite done, and I hope you can notice this, but we've been talking about how in your formulas your cation or your metal goes first, so these need to be switched. So our answer is actually CaCl2. So this is our empirical formula, our simplest ratio, 1 calcium for every 2 chlorines. All right, so let's do another example. It says determine the empirical formula for a compound containing 54.1% calcium, 43.2% oxygen, and 2.70% hydrogen. So this one has 3 elements in our formula, and we have percents. Now, when there are percents, the simplest thing to do is instead of writing a percent, we'll just write grams. Because if I have 100 grams, those percents would be the number of grams. Now you could make this more complicated and say, well, what if I had 3,270 grams? Well, then you could multiply by the percent to figure all that out, but that seems like a lot of extra work that I don't like to do. You'll get the same answer. So 54.1 grams instead of percents, calcium. So, oops, there we go. So grams of calcium on the bottom to divide out. Moles of calcium I'm converting to. 1 mole is 40.08 grams. All right, so this is 1.35 moles of calcium. All right, so let's do the oxygen. So 43.2 grams of oxygen. So grams of oxygen on the bottom, moles on top. 1 mole on the periodic table, oxygen is 16.00. So 43.2 divided by 16 will give me 2.70 moles of oxygen. Okay, and then my hydrogen, 2.70 grams of hydrogen. And grams of hydrogen, convert them to moles. 1 mole is 1.01 grams. So this is 2.67 moles of hydrogen. All right, so that was all step 1. So now step 2, I'm going to divide all of these by the smallest to get that ratio. So 1.35 is my smallest. So divided by 1.35. All right, so calcium is 1. So 1 calcium. This is 2 oxygens, and this is approximately really close to 2 also hydrogens. So I'm going to look this time first, and I'm going to say, okay, calcium is my metal, so that goes first. So Ca, one of those, 2 oxygens, so O2, and 2 hydrogens, H2. And this answer for our class for now would be acceptable, but there is a better answer. I'm hoping you can recognize that the OH is that hydroxide polyatomic ion. So a better way to write this would be CaOH taken twice. And this should hopefully make sense, just like the one above, because calcium is a +2, hydroxide's a -1, so you need 2 of those to balance it out. Just like if I go back up to this one, calcium again is a +2, chlorine's a -1, so I need 2 chlorines to balance it out. So that's how you calculate an empirical formula. We will do more examples in class.